Hello student, welcome to this video on adsorption and partition column chromatography. In this video, we will learn about the principle of absorption and partition column chromatography. We'll learn about the methodology and steps of absorption and partition column chromatography, advantages, disadvantages, and application of column chromatography. Column chromatography is a technique in which the substances to be separated are introduced on top of column packed with an absorbent which is passing through the column at a different rate that depends upon affinity of each substance for the absorbent and for the solvent or solvent mixture and are usually collected in solutions as they pass from column at different timings. It is a solid liquid in which the stationary phase is solid and the mobile phase is liquid or gas. So it was developed by American chemist D.T. Day in 1900 century, while M.S. Twist, the Polish botanist, in 1906 used adsorption column in the investigation of plant pigments. So we have studied this chromatography, definitions, and type of chromatography. Basically, we can use this column chromatography as adsorption chromatography because the stationary phase used in column chromatography is the adsorbent which is packed into the column. What is a column chromatography? Column chromatography is a technique which is used to separate single chemical component from a mixture dissolved in the fluid. It separates substances based on differential absorption of component to the absorbents at the compounds moving through the column at different rate, which allows them to get separated in the fractions. This technique can be used on small scale as well as on the large scale to purify materials that can be used in further experiments. This method is a type of absorption chromatographic technique. When the mobile phase, along with the mixture that needs to be separated, is introduced from the top of the column, the movement of individual components of the mixture is at different rate. That is like a differential distribution between the solid phase and the stationary phase. The component with the lower adsorption and affinity to the stationary phase travel faster when as compared to the greatest adsorption and affinity with the stationary phase. See the term, it is adsorption, it is a surface phenomena. The components that move fast are removed first, whereas the compounds that move slow are eluted out last. So it is necessary that substance should bind with the stationary phase and spend sufficient time in the column, otherwise the separation will not be possible. The absorption of solute molecule to the column occurs in a reversible manner. Selectively, it will get absorbed after it will move through the column and get separated out. Forms of column chromatography. There are two forms of column chromatography as liquid chromatography and gas chromatography depending upon the mobile phase used. If you are using liquid as a mobile phase, it is called as a liquid chromatography. If you are using gas as a mobile phase, it called gas chromatography. The most widely used forms of column chromatography are adsorption chromatography, partition chromatography, ion exchange chromatography, and gel chromatography. In case of adsorption chromatography, the basic principle is adsorption onto the stationary phase. In partition chromatography, liquid is held on the support and the liquid is used as a mobile phase and partitioning between the liquid stationary phase and liquid mobile phase is occurring in partition chromatography. In ion exchange chromatography, specific ion exchanger resins are used which will separate out the polar compounds. Gel chromatography, that is also known as the molecular sieve chromatography, in which The column is filled with a specific type of gel. The purview of this lecture is on the adsorption column chromatography, which is used in the laboratory. Adsorption column chromatography is a technique of separation in which the components of mixtures are adsorbed and surface of adsorbent. In partition chromatography, the stationary phase as well as the mobile phase are liquid and partitioned through the column. In gel column chromatography, this method of chromatography, the separation takes place to the column packed with the gel. The ion exchange column chromatography, the technique in which the stationary phase is always an ion exchange resin. So the laboratory adsorption column chromatographic technique involve the following steps, or we can say it a methodology of column chromatography. The first step is the selection of your chromatographic column, selection of adsorbent, preparation of adsorbent, developers, that is the various solvent systems which are used for the purpose, then packing of the column, then sample application, elution procedures, and detection of your separated components. So first step, that is selection of the chromatographic columns. Column made of glass with cork on other ends are commonly utilized in the column chromatography. Opening of tube is covered by putting a cotton or glass disc. Sintered glass discs are generally placed at the bottom of column, which serves as a support to retain the absorbent. The ratio of length to diameter should be greater than 20 as to 1. If your diameter is 1 centimeter, the length should be 20 centimeter. Tube of 20 to 30 centimeter long and 2 to 3 centimeter diameter are commonly used, which holds 50 to 100 grams of absorbent in the laboratory. The various stationary phase used in column adsorption chromatography. The stationary phase or absorbent in column chromatography is a solid. The most common stationary phase for column chromatography is silica gel. Remember that this is a plain silica gel. It is not silica gel G. Here we don't need any binder. So silica gel plain with the coarse particle size is used in the column chromatography, which is followed by alumina. Cellulose powder is often been used in the past for separation of dyes. The others are ion exchange chromatography, where we are using the ion exchange resins. In reverse phase chromatography or affinity phase chromatography, different adsorbents are used, modified adsorbents are used. The stationary phase are usually finely ground powders or gels and are microporous material for increased surface areas. The choice of adsorbent, there should not be any reaction which substance should be separated. It should be insoluble with the mobile phase and solvent which is used for the elution process. It should not catalyze or decompose of the substance. There should not be any reaction with the substance which is to be separated. It should have uniform particle size, shape, colors, and it should be inexpensive. It should have greater mechanical strength. The adsorbent used in column chromatography are classified as classification according to the bonding strength, as we have studied in the thin layer chromatography. Weak absorbent include sucrose, starch, talc, cellulose. Intermediate absorbent, which include silica gel, calcium carbonate, calcium phosphate, and magnesia. Strong absorbent includes alumina, that is aluminium oxide, and charcoals. The another way of classifying the absorbent use is classification according to the nature of material. That is inorganic absorbent. The examples include silica gel, alumina, that is aluminium oxide, kieselguhr, magnesia, and magnesium silicate. The organic adsorbents include cellulose and charcoal. The silica gel and alumina are sold in different mesh size as indicated by number on the bottle label. See the difference between the silica or the absorbent used in the thin layer chromatography. The absorbent particle size is very small, where the absorbent particle size is greater in case of column chromatography. Silica gel 60 or silica gel 230 to 400 are couple of the examples. The relationship, the larger the mesh size, the smaller is the absorbent particles. Adsorbent particle size affects how the solvent flows through the column. The smaller particles will develop the resistance for flow of column, which needs to use certain technique to increase the flow by applying either the pressure or applying the vacuum to allow the liquid to flow through the column. The smaller particle size, that is higher mesh values, are used in flash chromatography. The simple column chromatography used in laboratory is modified to the flash chromatographic technique, where two modifications are used. One is using movement of the mobile phase by the pressure, that is using the pumps or vacuum, and the detection technique. Here we can use the UV visible spectrophotometer for process of detections. The larger particle size, that is lower mesh values, are used for gravity chromatography. In laboratory, we are using the gravity chromatography where the mobile phase moves through the column by the gravitational force. For example, in laboratory, we are using the silica gel, which is having the 230 to 400 mesh size, whereas up to the 70, the silica gels are used in the flash chromatography. The first example of adsorbent used is the silica gel. Silica is a highly porous, amorphous salic acid in the form of a hard, opalescent particles, which is prepared by precipitation of water glass with sulfuric acid. Salic, silica special grades include silica FIA, that is fluorescent indicator absorbent procedures. Then silica E, having the particle size of 0.5 to 1 mm, that is 18 to 35 mesh, is used for determination of total amount of the combustible organic substances, especially used for organic separations. The another adsorbent used in column chromatography is alumina or aluminium oxide. Alumina is used more frequently in column chromatography than in TLC because it is quite sensitive to the amount of water which is bounded to it. The higher its water content, it will be the less polar side. It has to bind organic compounds and thus the less sticky it is. The stiffness or activity is designated as silic alumina grade 1, 2, or 3, with 1 being the most active. Alumina is usually purchased at activity 1 and deactivated by addition of water according to the specific procedures. Otherwise, it needs to be activated by keeping into the oven. Alumina comes in three grades: acidic alumina, neutral alumina, and basic alumina. The neutral form of activity 2 or 3 with mesh size 150 mesh is commonly employed for column chromatography. Now the preparation of adsorbent. The absorbent selected needs the activations, which can be accomplished by heating, preferably under the vacuum. Alumina is heated nearly at 400 degrees centigrade for 1 hour and silica gel is heated nearly to 200 degrees centigrade for 2 to 3 hours. The aluminium silicate or magnesium silicate or carbon which is heated up to 200 degrees centigrade for 2 to 4 hours for the purpose of activations. So we will end here the part 1 of column chromatography. See you in part 2 of column chromatography. Thank you and happy learning. See you in the next video. Thank you all.